So 1-5, we're now going to use the identities that you were learning in 1-4. And basically you just have examples. So we're going to write tangent of theta in terms of sine. So it means I only have sine. That's all I have. So I have my reciprocal, my ratio, and my Pythagorean identities available for me to use. Okay? So, what do we know tangent is?
Pi over x.
Okay, but function-wise. What function over what function?
Sine over cosine.
Sine over cosine. I'm going to leave my theta. I have my theta at the beginning. I'm going to leave it out as I work, and then I'll put it in as the end. Okay? So my numerator is good, correct? Sine. Do I have anything that allows me to write cosine in terms of sine? What function has sine and cosine only in it? So we have sine squared plus cosine squared. This is my off to the side thought, right? So if I want to solve this for cosine, what is it?
1 minus sine square root.
So plus or minus the square root of 1 minus sine squared? I think that's what you were trying to get out of there. So now if I replace this cosine with this, do I have it all in terms of sine?
Yeah.
Yes. And you do need to have the plus or minus there because you do not know which quadrant it's in. Okay, right. Secant tangent in terms... Secant tangent. It's just secant times tangent.
Oh.
In terms of sine and cosine.
Can I put parentheses?
If you want. If your brain needs it, go for it. Okay, so I have secant tangent. And I do want you going down. I went one step over and then everything else was going down because when we do proofs, we'll just go straight down. We won't even go over one. Okay, so I need terms of sine and cosine. So you're using your Pythagorean, reciprocal, and ratio identities.
So, like, we're doing it for sine,
We
and
could
then we're
do-
doing it for cosine?
No, you can have sine and cosine
Secant
in the answer.
Secant is 1 over cosine.
So secant is 1 over cosine. Does that make sense? You can have sine and cosine in your answer. And what's tangent?
Sine over cosine.
And so this says multiply, right?
Mm-hmm.
Yeah.
So you have sine of theta over cosine squared of theta. Now this one says write it in terms of sine and cosine. So we did that. But what if I just said now write it in terms of sine?
Then we would make cosine squared the square root of 1 minus.
Well, we wouldn't even have to take the square root because it's squared.
Oh.
So I could make it, if it's just in terms of sine, I could have it sine of theta over 1 minus sine of theta. or sine squared of theta. I wrote it, didn't say it. Make sense?
Yeah.
So you just got to watch what it's telling you. Okay. Add 1 over sine theta plus 1 over cosine theta. So when you add fractions, you have to have what?
Common denominators.
Mm-hmm. So, what?
Multiply by.
Each other, right? So we're going to multiply this by cosine and this by sine. So that gives me, well, gives me my denominator of sine of theta, cosine theta, right? And my numerator is just cosine theta plus sine theta. Now, it looks funny, but is that what the math would tell me to do? So multiply sine of theta plus 2 and sine of theta minus 5. So I'm just going to what? I'm just going to distribute. So what do I got? Sine squared of theta. And we'd have negative sine, a negative 5 sine plus 2 sine. So we'd have negative 3 sine. Minus 10. So if I can multiply it, can I factor it? Yes.
Yeah.
You factor this exactly like if I said x squared minus 3x minus 10. The factors of 10 that have a difference of 3. It's not x, it's what?
Sine.
Sine of theta. So then can I also set these equal to 0 and solve for them? Yes. Because sine of theta equals 5, which does not exist. That's out of it. And sine of theta equals negative 2, which doesn't exist either. But you'll learn that soon. Okay. Okay. These directions say simplify.
Why is there a line?
What?
Why did you separate them?
Because it's kind of it's the same, but it's completely different. Okay, simplify the expression x squared plus 9 after substituting three tangent of theta in for x. And that's the directions. That's legitimately what it says in your homework. So what do you need to do first?
Substitute.
Substitute 3 tangent theta in for that x squared, right? Or square x. So square root of 3 tangent theta squared plus 9.
So would it just be 3 tangent of theta plus 3? Simplify?
Well, you have to square it.
Yeah.
So wouldn't that be 9 tangent squared?
Yeah.
Okay. I missed, that's what you were trying to say. Sorry. Okay. Because when I square 3 tangent theta, I get 9 tangent squared.
How does, oh wait, in here.
Okay. Now what can I do with that inside there? Because I can keep going.
They can square root of all.
Mm,
Or,
this is a quantity, yep.
you can't do that to a quantity.
Nope. But what can I do with that quantity? I have 9 tangent theta plus 9.
Factor.
Factor out of 9. Can I do that?
Yeah.
Okay. So it's going to stay in the square root still. So I have 9 tangent squared plus 1. Something in your head should be going, this looks familiar, this looks familiar, this looks familiar. What did I say? Anytime you saw a squared function, you should be thinking what? Which identities?
Pythagorean.
Okay. So is tangent squared plus 1 a Pythagorean identity?
Yeah.
Yep. What's it equal?
Cosecant. No. Cotangent.
Okay, what's in the bottom of tangent? What variable?
Yeah.
X.
It's-
It is secant, but tangent, the bottom tangent is x, right? And the other one that has x in the bottom is secant? So this would be 9 secant squared, wouldn't it? Now can I take the square root of it? Alex wanted to take it up here. What's the difference between up there and right here?
It's not
It's not quantity anymore, is it? It doesn't have that addition problem. Because we can't add these two things, can we? Not as they are, because we don't know theta. But can we multiply them all day? Yes. So what's the square root of 9? 3. What's the square root of secant squared? Secant. Okay, so just so you know, if you see show, verify, or prove, they all mean to prove. They all mean to prove it. Show, verify, or prove. Obviously, prove means prove. But show and verify also mean prove. And then, so you follow proof steps. And I know that sounds funny. Oh my gosh. I cannot, my brain won't do it. And I'm going to do the steps. I'm going to show you. Okay, so this one says show the following statement is true by transforming the left side to be the right side. Okay? So I have cosine of theta, tangent of theta. So that means to do what with these two things? Multiply. Equals sine of theta. So we are proving, showing, or show, verify, or prove. We are not solving. Everyone clear on that? Solving means moving things left to right from the equation, correct? This says make the left look like the right. We just happen to know the answer. So basically we're simplifying that, so it means we can't add or subtract or divide, you know what I mean? We're making the left look like the right. We just happen to know the answer. So we're going to go straight down. You go down, and when you're done, you put a little box. Okay, so this is where our goal is. So we obviously want to turn these something, like what do you want to try over here? You got Pythagorean, reciprocal, or ratio identities. Probably don't want to put cosine into sine because then you have a square root. Because we had a square root in the first one, yes? We don't want to do that, do we? Not unless we have to. And you may have to. But what could we do with tangent? Sine over cosine. So I have cosine times sine over cosine. See, I'm lining my equal signs up. You're going to feel like you're doing Gauss-Jordan elimination because you're lining things up. Oh, those aren't very lined up, but they're lined up enough. Okay, the other thing, it's like Gauss-Jordan elimination, is you don't show things being crossed off. We're just big kids and we know it. Okay? So at this point, don't the cosine and the cosine reduce? So I'm left with just sine of theta equals, now we bring this down, sine of theta. We didn't change it, so we didn't do anything over there, and then you put your little box. It's basically the mathematical equivalent to a mic drop. It says, I proved it, you proved me wrong. If you look in your pre-calc book, every single example has a little box next to it. Every single example in this book, look what's there. Every single one.
Do you want to read
Yeah. See this? Every single example has that on there. You guys just don't know what it is. It's like a period. I'm done. Okay? So, the steps were straight down, line it up, and when you're done, the left has to look like the right. You can't stop here. Can't stop here. Have to do that last step. Okay?
Okay.
Easy to follow. Okay, the next one says prove. Well, show, prove, verify all mean the same thing, right? So prove sine of theta plus cosine of theta squared equals 1 plus 2 sine theta cosine theta.
Times cosine?
Yep. If I just say sine theta, cosine theta, that means multiply. The other thing is, you notice that on this one, I put my thetas at the beginning. I didn't put it in the second step, but I put it at the end. You'll have thetas and you'll have x's. It has to be at the beginning and it have to be at the end. I don't care in between. That's up to you. There'll be problems that I put them there because it makes it easier to look at. But for the most part, it's just writing a bunch of stuff. It's irritating. Okay, we can work on the left or the right. It doesn't matter. Good key is to start on the more complex side. The more stuff to do. So since I have to line these up, I put this here. I'm going to tell us we're going to work on the left. Why would I say on the left and not the right? There's more to it. I have to square this, correct? And I don't want to factor that. First of all, I can't yet. So some people will rewrite this. So this side is over here so they can extend and line up their equal sides easier. That's fine with me. I don't care. You can flip them. So if I multiply this, this is sine plus cosine times sine plus cosine, correct? Do I need to write that out or can we FOIL it without writing it out?
Yeah, write it out.
Write it out. Okay, so my next step obviously would be to FOIL it. And what would I get?
You get
Sine
sine
squared.
squared, sine cosine, cosine, sine, cosine squared.
So I'd have sine, cosine, so I'd have plus 2 sine cosines plus cosine squared. Now keep your eye on the prize. Keep looking over here. Got to end up with a 1. Do I have anything over here that is 1?
Yeah, sine squared plus cosine squared.
Sine squared plus cosine squared, and since that's addition, can I put it any order I want?
Yeah.
So sine squared plus cosine squared is 1. And do I have what I wanted? And when I say it has to be exactly the same, if you were to put 1 plus 2 cosine sine and 1 plus 2 sine cosine, I would count off half a point. I mean, it has to be exact. Okay. Now, knowing this, could we have gone and made this side look like this? Because we know 1 is sine squared plus cosine squared, right? Okay, so I have sine squared plus cosine squared plus 2 sine cosine. Well, then factoring, I would just factor it to sine plus cosine squared, wouldn't I? Which is the same as here. But which one was easier just to kind of naturally do? This left-hand side. Okay, so some things that might help you today is when you see tangent, try to write it as sine over cosine. It's not always going to be the best thing to turn every function you see into sines and cosines, but to start, that's a good start. Okay? When you see a squared, which identity should you be thinking about? The Pythagorean. If you have addition, you need to have common denominators. Yes? Sometimes that common denominator would be 1 plus cosine, and the other one's 1 plus sine, so you'd have to multiply them by each other. Okay? So, your assignment is, since I didn't get time to put it on the board yet, it is on Classroom though. 1.5, page 43, 3 through 51 odd,
3?
and 59 through 91 odd. Okay, how many days do you have on this?
1.
No,
3, don't.
you have 3.
Oh, geez.
That's why you have that assignment. Okay, you have 3 days on this assignment. When you come in on Thursday, I expect it done. Because we have our review on Thursday, our test on Friday. So if you're not done on Thursday, we can't answer questions and you will not be prepared for Friday.
Oh, so we're only doing a quiz over one section? What?
What do you mean
Friday
quiz?
is like that.
No, you have we have a test on Friday.
Oh, I thought you said quiz.
No.
And I was like,
I was trying to think back if I said quiz on accident. I don't think I did.